The psychology of reasoning is a branch of cognitive psychology that studies the way in which humans use logic to come to conclusions based on available information. But not all reasoning is valid, and people may use invalid reasoning to come to illogical conclusions. So just how logical are we as humans? And for that matter, how logical are you? A logic test developed by Peter Watson in 1963 revolutionised the field of reasoning. This classic selection task features cards with letters on one side and numbers on the other side. Subjects are then presented with 4 cards and a rule. If a card has a vowel on one side, it must have an even number on the other side. And the task is this: which card or cards must be turned over in order to determine whether or not the rule has been followed. So basically, you must turn over cards which can guarantee whether this rule is true or false. I'll give you a few seconds if you want to pause the video and think about it before revealing the answer. Okay, the correct answer is this. The cards which must be turned over are A and 7. These are the 2 cards which must be turned over to assess whether or not the rule has been followed. Various studies have shown extremely poor results for tasks like this, in which only 4% of participants get the correct answer, the most common wrong answer being A and 2. This can possibly be explained by confirmation bias. The rule mentions both a vowel and an even number, so it may seem logical to choose the vowel and the even number cards. While this may seem logical, as I will demonstrate, it's actually fundamentally illogical. I'll now go through each card and explain why you do or do not need to turn each card over. The key to this task is that you need to understand that you must try to falsify the rule, not confirm it. So the first card A, this is the most obvious, and virtually all participants correctly conclude that this card must be turned over. Because of course, if there's an odd number on the opposite side, the rule has been broken. Now the next card, the K card, this is basically an irrelevant card, which cannot give us any information. If we turn it over and it's an odd number, that's fine. If we turn it over and that's an even number, that's also fine. So if neither outcome breaks the rule, there's no need to turn the card over. The 2 card is where things get tricky and where most participants slip up. If we read the rule again, if a card has a vowel on one side, it must have an even number on the other side. Now, what's important to realise is that this rule only goes one way. Therefore, we cannot conclude that if there's an even number on one side, there must be a vowel on the other side. This is not the case. If we turn over the 2 card and there's a consonant on the other side, that's fine. This does not break the rule. And obviously, if we turn the card over and there's a vowel, this also doesn't break the rule. So again, if neither outcome can break the rule, then we cannot obtain any relevant information from this card, and therefore there's no need to turn it over. Finally, the 7 card. This card must be turned over. Why? To make sure there is not a vowel on the other side. If there is, this breaks the rule because the card has a vowel on one side and an odd number on the other side. So looking at both potential outcomes of all 4 cards, we can see that there are only 2 ways in which the rule can be broken, and therefore these 2 and only these 2 cards must be turned over. This rule is basically an if-then statement, or it can be written as P therefore Q, in which P is the antecedent and Q is the consequent. Each of the 4 cards represent the 4 possible premises: P, not P, Q, not Q. So P would be a vowel, not P would be a consonant, Q would be an even number, and not Q would be an odd number. Now, when presented with each of these premises, we can make inferences. These can be divided into 2 types of reasoning: inductive reasoning and deductive reasoning. Inductive reasoning is invalid, while deductive reasoning is valid. The first and most obvious is when presented with P, in this example the A card. Since the rule is P therefore Q, given P we can obviously deduce that Q must follow. This is known as affirming the antecedent, or modus ponens, which is a valid deductive form of reasoning. Next, when presented with not P, in this example the K card, we could infer not Q. This is known as denying the antecedent, which uses inductive reasoning and is therefore invalid. Just because you're presented with not P does not necessarily mean that not Q must follow. When presented with Q, people often infer P, but like I said, the rule only goes one way, so just because the rule is P therefore Q does not mean we can turn it around to say Q therefore P. This is known as affirming the consequent, which is another invalid form of reasoning. Now, finally, when presented with not Q, we can infer not P. This is often missed by participants of tasks like this, despite it being a valid logical form of reasoning known as denying the consequent, or modus tollens. This is valid because if we have a not Q, the only logical conclusion would be not P. If we apply this to a real world example, we could say something like, all tigers have stripes as our premise, then we could make inferences using both inductive and deductive reasoning. For example, if it's a tiger, it has stripes. If it's not a tiger, it doesn't have stripes. If it has stripes, it's a tiger. If it doesn't have stripes, it's not a tiger. Looking at the results of the card selection task, one might quickly jump to the conclusion that humans are not very good at reasoning and therefore illogical. But one important thing to note is that content is crucial to a task like this. Participants perform significantly better when presented with cards that have real-world applicable examples. This can be seen in a different form of the card selection task. This time, each card is represented by a person. On one side of the card is a drink in which that person is drinking, and on the other side is their age. Participants are presented with 4 cards and the following rule: if a person is drinking alcohol, they must be 18 years or older. The task is once again to turn over cards in order to determine whether or not the rule, or in this case the law, is being followed. In this case, 72% of people correctly predict that the cards beer and 16 must be turned over. The beer card has to be turned over to make sure the person drinking it is old enough. The water card is irrelevant since it doesn't matter what age the person is. The 25 card is also irrelevant since it doesn't matter whether they're drinking alcohol or not since they're over 18. And the 16 card must be turned over to make sure that person is not drinking alcohol. It's much easier for us to reason in tasks like this because we can actually apply it to real world scenarios. In terms of actual variables, this test is actually quantitatively identical to the first. The statement if a person is drinking alcohol they must be 18 years or over is just another if P then Q statement, where drinking alcohol is P and being 18 years or older is Q. The 4 cards also represent the same 4 premises as before: P, not P, Q, not Q. This also helps highlight why certain inferences are illogical. The most common wrong answer in the first task was the A and 2 cards, but as stated earlier, turning over the 2 card is illogical. The 2 card is representing the premise Q. In this real world example, representing the Q premise is the age 25 card, so it becomes more obvious why this is illogical. Just because a person is over 18 does not necessarily mean they're drinking alcohol, so no matter what they're drinking, they're not breaking the law, and therefore there's no need to turn over the card. So the rule P therefore Q cannot simply be turned around to Q therefore P. If a person is drinking alcohol they must be 18 years older cannot simply be turned around to if a person is over 18 they must be drinking alcohol. This is inductive reasoning and is therefore invalid. It's worth pointing out though, it's possible to be wrong using deductive reasoning, and vice versa, it's possible to arrive at a correct conclusion using inductive reasoning. Deductive reasoning is only as correct as its premise, so given an incorrect premise like all birds can fly, we could use modus tollens to logically deduce that if it can't fly, it's not a bird. This is obviously false because a penguin is a species of bird that can't fly. And if we return to our tiger example, if we see a tiger and say it has stripes, therefore it's a tiger, this is an invalid form of reasoning, yet we have arrived at a correct conclusion. In fact, inductive reasoning is actually incredibly useful and we use it on a daily basis with incredible accuracy. Some of the most obvious statements and assumptions we make are actually using inductive reasoning. Things as obvious as, the sun will rise tomorrow, or if I drop this coin, it will fall to the ground. These statements, though obvious, are actually using inductive reasoning. How do we really know the sun will rise tomorrow? Because it's risen every day of our life so far? But nothing that has happened in the past can guarantee what will happen in the future. We can only make predictions and increase the certainty of our predictions, but we can never guarantee outcomes. In fact, everything we know about the universe, we know through inductive reasoning. How do you think we get these premises in the first place? How do we know that all tigers have stripes? Through inductive reasoning. But there's no way to know for sure that all tigers have stripes. Maybe there's an undiscovered species of tiger in a jungle somewhere with no stripes. It's just that every tiger anyone has ever seen has had stripes, so we can say with a high degree of confidence that all tigers have stripes, but it's impossible to know for sure. In fact, according to the strictest rules of logic, it's impossible to know anything for sure. Through scientific research, we can only increase the likelihood that something is true, but can never actually confirm it. A famous philosophical quote states that nothing can be known, not even this. But just because something can't be known with 100% certainty, when all the scientific evidence points to something, any rational person would accept it as fact. So when it comes to reasoning, it's not just about logic, but also about common sense and rationality too. Thanks for watching.